and such like, and I've learnt quite a bit because I copy and paste and search on Google, and I never quite get the right answer to why my print statement doesn't work properly. But
I'll have you printing like a demon by the end of today.
You've cured a lot of problems already for me.
Oh, well, that's good to know. Thank you. Right, let's get cracking because we've got some ground to cover yet. So let's get back to this importing thing. Now, there are other subtleties to the way that you import things. If you're only interested in a particular object, then up until now, I've had to use you see here, I've had to use math.py to actually get at the pi object. If, however, I'm only interested in pi and I don't want to type math every time, I can express this import like this. So I can say from math import pi, and by doing that, I can then just use the word pi, and it does the same thing. So this is my namespace here. Now you can also apply a new namespace to an object. So in this instance here, I've got import math, but rather than just keeping it as the word math, I can rename it. So I can say import math as MT. So let me just go ahead and do that. And then I can say mt.py. Now that you might think, well, why would you want to do that? Well, some libraries are very long. They've got very long names, and there may even be sub-libraries within libraries. So that's a perfect example of where you would change the namespace using the as operator like that. If you the Python system has help built into it. If I do help math.log, for instance, which is logarithms, it produces a little help screen here, and that works in the REPL too. So if I go, everything that we're doing works in the REPL. So if I do import math, okay, so you know it imported because it didn't argue. If I'd have done import maths like that, it would have said no module named maths. So import math is what we need. If I now do help math.log, same thing. Let's just do that. I get exactly the same thing. So you can type this help in from the REPL as well, and it gives you help on how that actually works. Now, I'll come back to this help thing, because when you write your own code, you can build this help in automatically. It's really, really simple to do. So another nice thing about Python is that it's almost self-documenting as well. So and I'll show you this when we get a little bit further, when we look at functions, which we'll move on to fairly quickly. Now, it is possible to import all of the functions of a particular library. It's not particularly recommended, however, unless you understand what you're doing. So you can say from math import star, and that will import all of, do you remember up here we had, I've changed this now, but that did say math originally, didn't it? If I do math in there. So it will literally import all of this into your environment. So do be careful with that, because first of all, obviously, there may be names in there that you're not aware of and you want to use in your program, and that would cause problems. It's sort of frowned upon in Google land, in Python land to do the import star. However, it can be handy if you write your own. For instance, if you write your own library and it maybe only has 3 or 4 functions in it, then you can use that. And if you know what those names are and you're familiar with them, then that's fine. But by doing that, you can then just use the word pi again. So this piece of code will introduce pi. And there I've used the format command with the .4 just means 4 decimal places. So there we go. Sorry, 3 decimal places. It's always 1 less than the number that you use. So this is all. This notebook here is about working with libraries. So you've got that there to look at if you. My mouse jumping all over the place. It's Zoom that's doing it, I think. That's annoyingly in the way. Right, so we've finished with working with libraries. So back to our plotting. So what we're about to do is we're about to use a library. So here's an import. Now this is a non-built-in library. This is a library that you're going to have to install on your machine if you want to use it. But this is a bit like MATLAB. If any of you've used professional plotting and manipulation tools, it's an open source version of that. And the bit we're interested in is this plot. Is this PyPlot. Matplotlib is a huge library. PyPlot is just about plotting. And so that's what I'm going to import in here. Now this instruction here, let's just separate those two for the moment. This first instruction has a % sign in front of it. And that is what is actually a command to Jupyter Notebooks. Jupyter Notebooks has a whole host of commands, which are up here somewhere. I think actually I don't know where it is. It might be in Notebook Help. There are a load of commands that you can issue the notebook, and it's basically an instruction to the notebook to behave in a certain way. So this wouldn't appear in a program particularly, but it is specific to notebooks. And what it does is it makes sure that all the plotting of graphs and charts and things that we're going to use ends up in our notebook rather than elsewhere in a window or something. So that's what this %matplotlib inline, it prints everything out in line. The actual Python bit is this bit here. This is importing the PyPlot thing. Now Matplotlib, let's just go and have a quick look at Matplotlib. This is the website for Matplotlib. It's matplotlib.org, and it's a fantastic toolbox. And anybody doing anything in data science is going to be using Matplotlib pretty much. You can install it using pip, so you can just do pip install Matplotlib. That's all you need to do if you've got pip already installed. So it's really quick and easy to get in to load up. Now, there's no real need to buy any books or spend any money learning Matplotlib, because this website is excellent. If you go into the examples section, they give you examples. I mean, if you look at something like a very simple, say, a chart like that, if you click on it, it shows you what the chart looks like, and it gives you the code and how to produce it. I think they start off with something quite simple. They probably, I don't know, horizontal bar chart, that would be quite simple. So there's the code to generate that. So there are one or two charts in here in this gallery, and in fact, if I scroll down, you'll start to see the scale of this. So when I say plotting and charting, I really do mean plotting and charting. So in fact, we've got 10 minutes. There's charts here that I don't even know what are, and it goes on and on and on. There's a simple one, look. So geographic projections, it could be pretty good for radio astronomy. Not difficult either. I mean, look, that is created with that bit of code there. And we're going to learn how to use this. It's an absolutely fantastic library. And you bored yet? I'm going to have to stop because we've got other things to do. But you can see that literally, I don't know whether it's making you feel sick, because it is me. Even animated plots, look. It goes on and on and on. It's fantastic. So go and read up on that. Whilst we're on the subject of books, I can wholeheartedly recommend this here book. Some of you might have seen it on the shelf. There's absolutely no need to buy this book if you don't, unless you, I mean, I do like books, but they are expensive. The entire book is available on this is their GitHub site. It's called Python Data Science, and it's on GitHub. I put a link into the Jupyter Notebook to it. And if you look here, read this book in its entirety. So the entire book is available here. If you go down to visualization with Matplotlib, it starts here, and you might recognize the format. This is a Jupyter Notebook book. So they actually have all the notebooks. You can go in there and you can run them just like I'm running them. So these are all this, that's how you would do a sine wave chart. There's the code. This book is one of the best books on data science, on data science that I've read anyway. And it's an excellent book. And of course, it's freely available on GitHub. So that makes it even better in my eyes. Back to reality. So let's get back to my exercise here. So all we have to do is import the library. So let me hit that. You'll see that the little star stays up there for a while. It's quite a big library. So if you do that on a Raspberry Pi, it takes a little bit longer than that. This is an i7, it's an octo-core i7 with I don't know. It's a pretty powerful machine. So how do we plot? How do we do a plot? Well, what we do is we've imported the PyPlot as PLT. So all I need to do is do plt.plot and give it some data, and it'll plot it for me. So I've got 4 values. Now this, we haven't covered dictionaries and lists and tuples and all the different objects, but this, for anybody that is new to Python, is called a list. It's an array type. It's characterized by the fact that it has square brackets on either side, and each element of the array is separated by a comma. In fact, all arrays in Python are arranged in the same way, and whereby the elements are separated by commas. Now, what characterizes a dictionary is curly braces, and what characterizes a tuple or a set is curved braces. So the square brackets like that mean it's a list. Lists have a particular way of working, and I'm not going to dive into huge detail in that, but it's basically 4 values in an array. You can pass any array type anyway into plot and it will deal with it. In fact, we're very quickly going to be using some very specialized types of array. So this is just an ordinary set of values. I've got 1, 2, 4, 2, just 4 values. If I plot that, I get a graph. So that is how easy it is to get yourself some data onto the screen. Now, obviously, we can make it more sophisticated than that. What this does is it automatically says, right, you've got 4 values. It's obviously a sequence of values. So I'll give you a sequence along the x-axis, and the values themselves will be represented on the y-axis. So that's what its default behavior is. You can obviously then override that, and you can change the axes, and you can change the style and the color and the thickness and the type, and this is just the basic way of plotting some data out, and very useful, as you would imagine. It automatically ranges it and labels it and does all those things for you. That's its basic standard behavior. However, you can do something more complicated. Now, fairly quickly, these lists of values, well, they're okay with the lists of lists in Python. In fact, lists are a fantastic tool. But when you're dealing with scientific data, quite often you're looking at signed floating point, large signed floating point values, even other number types, special numbers, and multidimensional vectors. There's all sorts of mathematical trouble we get ourselves into in radio astronomy. If you're dealing with those sorts of numbers, then there's another library called Numpy. And Numpy is a fantastic library, one of the king libraries in Python. what NumPy is a whole library full of number crunching tools. It's highly optimized. It has much higher performance than the standard Python tools, or some of the Python stuff has caught up over the years. But if you want to crunch numbers, then yeah, NumPy is definitely the library you want to be using. Tradition usually says that you import NumPy as NP. You'll see that a lot. So we're just changing its namespace so now we can just call it NP. That's all that means. So I'm going to create a NumPy array, and I'm going to use a command which is in NumPy called linspace rather. And what linspace does is it creates an array of numbers starting at one number, ending at another number in steps, and that's what these three values are. So what I'm asking it to do is create me an array which starts at -4, ends at +4, and jumps up in steps of 5, and then just print that out. So this is and it basically does it. As you can see, because I started at -4, that had to be the lowest value, or rather the 5 values. It linearly spaces those values out. Sorry, it's not the last number isn't the step. I misled you there. Sorry, the last number is the number of elements that I require. So if I did that as 10, just to show you that, I'd have it with 10 values. Obviously, they wouldn't be whole values because it's not subdivisible. But I've got -4, -2, 0, 2, and 4. You'll see that in NumPy, all the elements are, unlike this one here. Can you see these are actually integer values? These numbers here, this list here. In fact, if I just let me just do this instead. I'm going to do x equals that. So that's my list. If I just do x, you'll see that it says 1, 2, 3, 1, 2, 4, 2, which is that. But you'll see that it just is a 1 with a comma, which is different from this, this is got the dot there, which means it's floating point. So all values inside NumPy arrays are floating point. So that's a distinction between an ordinary list and a NumPy array. So that's one thing to bear in mind. Yeah, this is a little tip on Jupyter Notebooks. Actually, it's saying that if you want to know more about a particular function, so say you come to this bit and you want to know how to fill that in, you do the open parentheses, and then you do Shift and Tab. So if you do Shift Tab at that point, what happens is that you get a help box. Can you see here that tells you what values you can type into the parentheses? So there's an additional. Remember before I just did Tab and it showed you all of the actual library functions. Well, this is once you know what the library is, you can hit Shift and Tab, and then you get help. So it's saying start, stop, and in fact, if I plus on there, you've got start, stop, the number. In fact, it defaults to 50. I'll talk about that as well while we're here. I don't know what that means, and I'm not sure what those other ones mean. You'd have to actually look those up in the documentation. Wherever you get an equal, when you get parameters like that where it says num equals 50, that actually means it's a default value. So it means if you don't specify num, which is the third item, so we've got start, stop, and num. So do you remember we did what we did? We did -4 to what was the second value we did? Was +4, and we wanted 5 of them. If I didn't put that in, it would default to 50. So if I do that, of course, you get 50 of them. There you go. So that's what. Whenever you see the equal sign in a declaration like that, that's the default value. So if you want 5, put 5 in there. Or you can, if you want clarity, you can put num equals 5 in there as well. That's exactly the same. So that's optional. So let's have a look at what our next one we've got. A equals 1, B equals 1, C equals -6. So we're then going to create a Numpy array called X. X equals Numpy. We're using the linspace again. So between 4 and -4 and +4, we're going to have 100 elements in it this time. And then we're going to compute for all values of X. So we're going to say Y equals X times X to the power of 2 plus B times X plus C. So the weird thing here is that this is actually X is an actual Numpy array. Now, Numpy arrays are really clever. They know that what we're trying to do here. So what instead of this being one single value, this is actually a whole array, which means it's going to apply this actual algorithm to the whole array, not just one element of it. And then we're just going to print it out at this point in the first instance. So we'll do that. There we go. So it's actually put this linear regression onto all our values there. So if I want to plot that, I just do plot plt.plot xy, because I've got values for X are the actual ones here, and then the one. In fact, we're going to get a graph with our it's not a linear regression, is it? It's a I don't know, what do you call that? I've forgotten. Maths isn't my forte, I'm afraid. But this is just to show you the power of Numpy arrays, is that you can actually have expressions. So this is excellent for filtering data. If you want to reduce the value of data, or you want to range it, or you want to compress it or modify it in some way, you can use a Numpy array like this to very quickly alter all those values without having to write loops or anything like that. It's very efficient as well. I mean, it's pretty quick to do that. Let me just get rid of the print so that but if you're just doing a plot here, I mean, that's pretty snappy. I mean, okay, it's only 100 data points, but I think it's pretty cool. Let's get on to the next section where we are time-wise, not doing too bad now. So you can, using the plot again, we're going to plot this particular graph here. You'll see that you can also change the labels and the title. As you'll imagine, all of those things are accessible. So that's a plot. I've also added a line width equals 6 in there, so you can obviously, do whatever you want in there. You can have line width. You can change the colors, all the rest of it. This is actually, let's just see what this is going to do for us. This is actually 2 plots, one after the other, as you can see, with different values in there, just to show you some of the things. Colors are represented with the default is blue. You can have red, or you can have orange. There's tons of different colors. No, that means use zeros. I can't remember what all the colors are, but you can look those up. So there's an exercise for you there for anybody that wants to have a go at using Matplotlib at that point. There are different styles of plot as well. So this is another simple linear spacing of values in a Numpy array, and with an algorithm similar to the one before, in fact, that's exactly the same style. I don't know why it's saying style on there. The code in the previous cell is difficult to read. Oh, I see. It's talking about programming style. Sorry, I'm a bit slow here. Yeah, that's all sort of bunched up. Can you see how this algorithm here is all really difficult to read? what it's saying here is that you need to put some space between it because it makes it easier to read. That's what that's about. Okay, so this is colors. So I'm not going to dwell on these endlessly, but there's loads of examples here. So this is 3 plots. That's very simple. I've got values of got 4 values in 2 values on each axis, if you like. This is the changing the color of that particular one. So that's 3 plots, and then with a legend. So you can put a legend in the top here. It's endless stuff that you can do with Matplotlib. You can even use, look at these colors here, fuchsia, lime. I don't know what Dodger blue is. It must be, is that a football team in America? Is it the Dodgers? It is, I think, isn't it? So you can make them look pretty pretty. This one's even got XKCD : baby. Don't know what that is. Puke green. Forgive me, I have no idea what that must be. The guy from TU Delft's sense of humor. There's obviously a color called puke green. The gallery of graphs is, I've already shown you. There's a link to it there. As you can see fairly quickly, this plot command is super powerful. And if you choose the right type of graph, you can have literally anything you like in there. I'm not going to do any more on that. So any questions about Matplotlib so far? What I probably will do at this point is image manipulation using, I'm just going to go and have a quick look at NumPy, because I think that the explanation of NumPy in that section is slightly, there's a few things that I'd like to just talk to you about in NumPy, because NumPy is another library which I definitely recommend you all to become familiar with. I've even put BAA logo on this one. That's getting posh now. So import NumPy as MP. There are lots of commands like this, for instance. I mean, they're not necessarily that useful, but they can be if you're doing, when you're working with data. But if you want to create a NumPy array of zeros, 10 in this case, just do that. You get 10 zeros. As you can see, they're all floating point. That's the point trying to make there, that all these values will be floating point. If you want to access any element of an array, and this applies to all arrays in Python, so this is exactly the same syntax regardless of what type of array it is. So this is a NumPy array. This would work for a list or a dictionary or a tuple. You use the square brackets and the number of the element. All arrays are numbered from 0. So the first element, this one here, is 0, and this one here is 9. That's how all arrays are indexed in Python. So if I actually knocked off type from there to start with, I would just get that first value. So that's just 0.0. This is the value of the first element. What I'm actually going to do here is do the type command, just to show you that the type is not an ordinary float, it's a NumPy float, 64-bit floating point value. So just bear in mind that NumPy has slightly different types as its element. And if you're ever unsure about what you're dealing with, just use this type command. You can see I'm using this quite often. And when I'm doing data analysis, I do use the type a lot, just to make sure that I've got the right, I understand what the type is. There's some really good commands in there. So for instance, we've got our array, which is called A. It's a NumPy array. You can do things like shape, and it'll give you the actual shape of the array. So it's 10 elements. It's just a single array. It hasn't got multiple elements. But if I do a 2-dimensional, so this is a 2-dimensional array. So it's a pair of square brackets and then there are two sets of square brackets separated by a comma. So that's the first element has got 10 points in it, and the second element's got 10 points in it. So if I run this piece of code, you'll see that shape is now 2 by 10, and I can have as many elements in my array as I like. There can be 4, 5, 6, 7, 10, 12 dimensional arrays. Good luck. They get big. But again, very, very useful. This is, I've shown you this already. So if you do B dot and hit the tab key, because B is as we know already, is a Numpy array. It gives me all the methods that I can use with a Numpy array. So, for instance, I can say data in there, and it'll. No, that's not what I thought it was going to do. What was I looking for in there? I think there's one called info or something. Fill that. Number of bytes. I suppose that'll just tell us how many. There are 80 bytes in it. So you can see how you can experiment, which is not as easy to do in other languages as this. You can just experiment with this and work out what things are. So you can make it look like you even know what you're doing even when you don't. Which is what I'm doing right now. So if you want to find out what the maximum value is, just do that. You've got to, because it's actually a function, you've got to do that. That's just one little thing worth knowing about. If you call a function like that and it says it's a function, what it's doing is it's telling you that what this command means is what are you. If you want to actually execute a function, you have to put a pair of parentheses at the end of it, and then it will actually run the function. And in this case, the maximum value is 10. And that, of course, that's in both arrays there. If I wanted to specify in the first array, I would do that. And it would still be 10, of course, unless let me make one of them. This one's got 11 in it now. So if I run that now, I run that, that should still, that's 11. And then if I run that, this is this array, which the maximum now should be 10, which it is. So you can see how that works. So if I don't specify which array I'm interested in, it will look through the whole array, and then it will be 11. Again, question mark B, if you run that, you get a pop-up which shows you what the object is, and it gives you a complete help file all about that object. So this is all the help for Numpy array, for a Numpy array. And that's a Jupyter thing, that question mark. It's not a Python thing. You can't do that in a REPL, it won't work. In the REPL, you could type help, and it would give you something similar. So let's have a look at these elements, because that's pertinent to what we're talking about here. We're definitely not going very quickly here, are we? Yeah, I'll do this. Yeah, this is useful for you guys, because you want to learn how to manipulate your data, don't you? Let me just run this. It will probably make sense. 0 gives me the first element, so that's my 1, 2, now 11. All of these are the first element, so it's that very first group. If I want to just take start at position 0 and take and go to position 4, then, or rather take the first 4 elements, then I do 10 as I do 0 colon 4, and that gives me 1, 2, 3, 4, because that's the first 4 elements. If I want to do that, and so this one is the start, the end, and then this one is the jumps. So it starts at 1, and then it jumps to 3. There's only want 2, only 2 in there. This one is slightly weird because this is, if you do colon colon, it means from the beginning to the end, and if you do -1, it means in reverse order. So you can see now I've got my array reversed. Now, these seem sort of incidental, but they become quite useful when you start looking at things with your data itself. So what I'm going to do here is I'm going to import using, there's a library here, yet another library called SK image, and it's useful for actually bringing in images. So I've actually got an image on my system here, JPEG, and I'm going to read that image in as a Numpy array, so that it becomes a 3-dimensional array. Here's my Numpy array. If I have a look at the shape of it, you'll see that it's 799 pixels by 975, and it's got three layers, which are red, green, and blue. That's how images are made up. Now, this obviously I'm doing it with it as an image because I think it shows you, it's easy to understand how these elements purport to the data. But of course, a lot of the time this might be information from an SDR where you've got P and Q data and that sort of thing, where you're trying to manipulate them en masse. So it's easier to visualize with an image. That's why I've done it with an image. So if I want to show the photograph, I'll just do that, and that's my photo. It's actually a photograph of it's just what I had kicking around, but it's this was a project. I do work for a charity, and this was a project for a guy that had motor neuron disease, and he needed an alarm to alert his carers, and he could only blink. So this is actually a camera here, and this is a Raspberry Pi in a box with a screen on it. And if you looked at this was mounted at the foot of his bed, and when he blinked, he had to blink 4 times, I think, and this was a counter, and it detected him blinking. So he blinked 4 times, and then there was a little radio transmitter in there, and it alerted the carer that he needed assistance, because he couldn't press a button with his finger or anything. He lost all of his ability other than blinking. So and that was all written in Python, so I thought it was permanent. So here's my photograph. I've plotted it out just as a plot, so we can see the pixels. So we've got 799 pixels by 975, and these 3 elements here are the 3 colors, red, green, and blue. So we can manipulate this now by using these what do they call these? By using this, I can't think of the word. So if I do that, what I've done there is I've inverted all the values. So I've flipped it. I flipped it from left to right and from top to bottom. I've actually flipped the colors as well, but it doesn't matter. It just sort of works out. That's flipped all the values by doing that. If I want to take that data, and what this is going to do is actually just flip 1 axis. So this is the notation for that. So you're going to have to learn about this notation, and this applies throughout the whole of Python. So the best thing to do with this is just get yourself some data and play around with it, and you'll soon get to grips with what this does. So that's flipped my data horizontally. If I want to zoom in on my data, I just literally say I'm only interested in these bits of information. One thing to look out for, which I found a bit weird when I started using NumPy, is that if you look at this here, you'll see it's numbered from the top down and from the left to right, which sort of, but this top down business is a bit weird, which is the way that the graphics library, the SK library, portrays images. They're always numbered from the top left corner, which caught me out for quite some time. So if I want to take a zoom in on this picture, all I say is I'm interested in from here to here and from here to here. So I've now got an image which is zoomed in. So it's just that section there. So again, if you've got some data and you want to exclude parts of it, that's quite easy to do, to sort of subdivide that down using a Numpy array. This one here is going to change the, is going to scale it down. So what I've done there is that actually has divided the value by 10. That's what that function there does. So I've actually got, well, it hasn't, it's taken every 10th position. You remember we did it earlier in a numeric sense, but you can see I did it sufficiently that you can see that the resolution of that is now dreadful. So it's basically, unfortunately, this plotter always scales it. So if you were doing this elsewhere, you would see that that would shrink. It becomes a much smaller image, and that's how I've done it. What does this one do? This is just simply shows me the minimum and the maximum, and that's quite useful. I mean, obviously it's an image, so all the values are between 0 and 255. You can see the min value is 0, that's 255. The mean value, I don't know whether that's at all useful, but I can manipulate those values then. So I'm going to have a changed photo where all the values that are greater than 100, I'm going to make 255, and all the ones that are less than 100, I'm going to make them 0. That's what this statement here means. It's a NumPy command called where, and it basically just goes through all my data, and it says if it's above this value, do this. If it's below, do something else. And then I'm going to display it, and it's simply basically going to increase the contrast of the image. That's contrast controls. Now there are other image. If you're interested in image manipulation, there are libraries which use this, but they put it into terms which are easy to understand. So you can use a library called contrast, for instance, and it will do the same thing. But if you understand how numbers work, you can manipulate them directly using these NumPy commands. Again, this is purely just to I'm only using an image just to give you that impression of the effects that we're having on the data without having to go into great detail about physics. That's the thing I'm trying to avoid. So that's Numpy arrays. They're very, very useful when you're doing data manipulation. Let's, we've got a question. I didn't notice, sorry guys. Oh, polynomial, that's the word. Yes, thank you. That was the curve, wasn't it? It's a polynomial, that's the one. Why did I forget that? Right. What I'd like to do now is probably jump to looking at some of the other platforms. I think we've had a reasonable introduction into the how to present your data, and I think Jupyter Notebooks you can see are very useful. You can see why they're very handy for presenting your information as well, and also whilst you're learning, because you can make notes as you go. So it's definitely something that to look into. Now, when I'm programming most systems, I use an actual programming editor, and there are lots and lots of those around, ranging from some quite simple ones. And let me just go and give you a flavour of what those might be. The sort of ones I would recommend, if you're an absolute beginner and you don't want to have to learn a lot, then there's a program here called Thonny. Now, Thonny is nice for a number of reasons. First of all, it's very simple. It only has relatively simple controls in it. It's not a huge, great Leviathan. It's completely written in Python. If you're interested, you can download the source code because it's open source, and so it gives you an idea of what you can actually do in Python if you put your mind to it. So Thonny is quite good. It works quite well with Raspberry Pis and such like. But my everyday editor is in fact Visual Studio Code, which is this here. So this is Visual Studio Code. Visual Studio Code is a much more grown-up environment. It's the Microsoft's best offering. What can I tell you about Microsoft Visual Studio Code? It's quite simple to. It's not bad to learn. It's quite simple and clean cut, but it has a lot of sophistication built in behind the scenes. The other fantastic thing about it is it's got lots of really good plugins. And in fact, down the side here, you've got the ability to view all the things you're working on. So in fact, this is the actual project on the GitHub site. So you can see there's all the folders that you saw on GitHub. And in fact, this has got Git integration in it. So I can make changes here and they're uploaded onto the GitHub site when I make the changes. So that's really nice. The version control is here built into it. So down the left-hand side here, yeah, you have things like version control. So it's showing me the things that have been updated and I need to check in for my versioning. So that's nice. It also has plugins, and that's what I want to talk a little bit about. The first thing I'm going to probably look at and talk about is, let's start with a Raspberry Pi. We've got an hour left. We've got Raspberry Pis, ordinary Raspberry Pis. I've got RTL dongles, and I've got Raspberry Pi Picos to talk about, and I've got a couple of projects on a Pico. I don't know that I'm going to get them all in, so which one shall I work? Let's see what we got here. What do you think about Spider as coding environment? Yes, Spider. I didn't mention Spider. I do use Spider. Spider. I know that there's some people here are new to Python thinking, what are all these things? But Spider is another great environment when you're experimenting. So I'm glad you mentioned it, actually. I was going to show you all and I promptly forgot. I don't know where it is. It's loading up somewhere. There you go. There it is. Yeah, Spider is a tool which is a sort of halfway house between Jupyter Notebooks and an editor and a REPL. It's all of those things in one place. What do I mean by that? Let me show you very quickly because we're running out of time. Go away, go away. Don't want that, go away. This bit down here is your REPL. So you can actually go in here and you can say print hello world. Like that. Although you need quotes around that, otherwise that'll fail. It'll do hello world. So that's your REPL. But you've also got code up here. So this is an editor. So I can come in here and I can edit just like I would normally. But I can then hit play and it runs it in my REPL. So it's an editor which you can constantly check and try. And you see these numbers here. This is very much the same as in Jupyter Notebooks. It's slightly nicer than Jupyter for some things because it's got a debugger built in up here. So if I look at Variable Explorer, you can see that I can see all my variable values in here just at a glance without having to come down here and type in actually there are no variable. Oh, I've got a variable called I. If I do I, you do that and it says it's an O. It's got the viewer up here for variables. So yes, Spider is pretty cool. It's got a debugger where you can step through your code as well and see all the variables dancing around, which again is very handy. So Spider, yes, thank you for pointing Spider out. I didn't want to sort of bombard you with too many of these, but yeah, have a go with. I do use Spider depending on what I'm doing. If I'm doing more sophisticated code and I'll sort of test it and get a feel for it, I'll sometimes use Spider. Two more questions. Let's have a go here. What have we got? Come on. Doesn't Thonny do all that as well? Doesn't Don found out help modules shows all libs and modules? Oh right, you do help modules, do you? Right, okay. I didn't know that, but how exhaustive that is, I don't know. Doesn't Thonny do all that as well? Well, Thonny does quite a good job. It's nothing near what Visual Studio Code does now. Visual Studio Code is way more features. But for some people, that's quite complicated. The other reason I like Visual Studio Code is that I use it in my day job. I also use it for programming Arduinos. I use it for programming Windows. I use it for, you can even run Jupyter Notebooks in it. So I can actually open a Jupyter Notebook directly in here. Let me go and show you how that works. If I can find one, Python. Where is the Jupyter Notebook in there that I want to open? There's one that we've just been playing with, wasn't there? There we go. Untitled. Working with libraries. That was the one we worked on. So if I click that, there's your Jupyter Notebook directly, actually in Visual Studio Code. It doesn't come out quite so well because I use a dark theme in here. So, but if I do import math, I can run that, and then I can run that. He says, there we go, it's run. And then if I run that, well, that's because I put a question mark in front of it. Of course, that's not compatible with this. There we go. So you can actually run a Jupyter Notebook in here. So this has got loads more capability than Thonny. As I say, you might not want that, but it's up to you. Now, I'm going to start talking about Raspberry Pis very quickly. More about the way of working on Raspberry Pis, because Raspberry Pis are just Linux machines. They come already preloaded with Python, so that makes life a little bit easier, but it's very easy to get a lot of the libraries onto a Raspberry Pi as well in the same way. So working on a Raspberry Pi has advantages from the point of view of obviously very low power, very small and cheap, and you can put them on a rooftop or in a garden or in a shed at the bottom of the garden or on the dales, or you can even run them on batteries. Certainly, to some extent, you can. They have a lot of grown-up features in them. They've got USB support. They've got obviously support for things like I2C and all of the other interfaces that you're probably going to meet when you're doing data collection. So they're quite good for that sort of thing. You can put flashcards in them, so you can store all of your data on those. They've got connectivity, Ethernet, both wired and wireless, depending on the model. So they're a great little product for this game, is what I'm trying to say. Now, working with them, there's a number of different ways you can work with them. If you have a Raspberry Pi, one of the bigger Raspberry Pis, then and you're running a graphical interface on them, so you're actually running X windows of some shape or form, then obviously remote access can be gained through usual suspects, and I'm just running VNC Viewer, which seems to be taking a while to run for some reason. Come on, VNC Viewer. Right, there we go. So I've got my Raspberry Pi hooked up over on my desk over there, and there's my Raspberry Pi. So this is obviously a VNC session. From here, I can actually program directly on it. So I can open up, well, there's a Python, the Python is there. So I can say, print world. Stuff, this, isn't it? And that's me programming on actually physically on my Raspberry Pi. That works fine, isn't it? It's a way of doing it. Now, I like Visual Studio Code as you've already worked out, and you can actually install Visual Studio Code on a Raspberry Pi, and it works very well. But the way that I like to work is I like to work on my local machine at the same time as being able to test my Raspberry Pi. And quite a lot of the projects I do, I don't have a graphical interface like this, so I can't actually use VNC or one of the screen scrape technologies to get at it. So a lot of my Raspberry Pis are what would be termed as headless. So I only have a very minimal install of Linux on them. In fact, on the Raspberry Pi website, there is a headless version of the operating system. Now, if you've got a headless version of the operating system, what you have to do then is you have to attach to them, usually using SSH, basically a remote terminal. So in that instance, I'm just going to shut this down. In that instance, I'm working on a PC. So on a PC, you don't have SSH support built in. So I'm using PuTTY. You may be familiar with PuTTY. My Raspberry Pi is on the other side of the room there, and this is what it would look like if I were logging on to a Raspberry Pi, a headless Raspberry Pi. So I just run an SSH session like this. The user's Pi, put my password in, and then I'm in, and off we go. Now, editing a Pi file on there I can do from here, but of course this would involve using a command line editor, something like Vi or one of those, and they're not my favorites. I spend so much time in Visual Studio Code that I want to work in Visual Studio Code. So there's a really neat way of doing that, and it involves using a let me just, I think I created a workbook for this. Is it under, what did I put it under? Bear with me for a moment. Working with libraries, diagrams, manipulation. Maybe I didn't get around to it. Must not have done. I thought I had. Let me just type in what you need. No, I did. I did do this. I did do it. Because I remember doing the screenshots for it. Hang on a minute. I definitely need to find it. Sorry about this, guys. Under there. Yeah, here it is. It's this one here. Now, Visual Studio Code supports a mechanism called remote or remote Visual Studio Code, or RMate. If you, I've created this workbook is obviously on my GitHub, so it's got the links in there. If you click on there, it takes you to the website. And this tells you how to set it up in PuTTY and everything. Very briefly, what happens is that if let me just go back to Visual Studio Code. Forgive me if I'm jumping around a bit here. If I click on, see this icon here that's got the blobs on it. This is all the plugins that are in my Visual Studio Code, and also it's a full library of plugins. And if you go to here and you type in RMate, something like that, you'll find this plugin here, which is called Remote Visual Studio Code. Now, I already have it installed. You can tell because if you haven't, this would say install, and at the moment it says uninstall or disable. So this is the Remote Visual Studio Code plugin. And if you read down here, again, it gives you the instructions of how to set it up, and it's completely compatible with Raspberry Pis or any remote machine that you want to work on. So you put this plugin into Visual Studio Code. That's the first thing you do. Let me go back to. Oh, there's a question. Whilst I'm here, other IDs do remote coding. Other IDEs that do remote coding. Is that a statement or a question? I'm not sure. Other IDEs that do remote coding. Don't know really what that is. Right, where was I? So we go back to my Jupyter Notebook. You add the plugin, and then if you're using Windows, you can configure this using PuTTY. If you're on a Linux machine, then there's a command which it shows you in the help for the remote. I've actually shown you how to set this up. And basically, it's a tunnel. You can see here it's I've clicked on tunnels under SSH. It's tunnels, and you have to add this line of code in here. And what that does is it uses SSH to tunnel this information in and out of your computer. And it sounds a bit cumbersome, but are there other IDs that do this, e.g. for Mac OS? For Apple, yeah, Visual Studio Code, that runs on Macs. It's multi-platform. So you can use Visual Studio Code. I dare say there are others. I don't know Macs terribly well, I'm sorry. I use Linux predominantly for my own machines, although I have got this Windows machine, and I use Visual Studio Code on them all. So you set up oh, I lost my train of thought now. You set up PuTTY for this tunnel, and this is exactly the connection I've got. So this is actually a tunneling connection that I've actually got now. So once you've got that and you want to edit something, all you do is I've got a directory on here called array, and I've got I want to actually edit something in here. So what we're going to do is in Visual Studio Code, let me just bring that up here. So let's get rid of all of this stuff. In fact, I can get rid of everything in here for the moment. So this is Visual Studio Code running in the background. If I bring up my PuTTY screen here, so you can see both, you go to your Raspberry Pi and you type rmate, and then whatever file is that you want to edit. And I'm going to call this GPS test or something like that, or GPS test.py. So this is the name of the file I actually want to edit. Hit return, and what happens is that it uses that tunnel, and it automatically, oh, it's in the wrong one. Sort of spoiled the illusion somewhat. Let me do that again. 1 minute. Oh dear. I've got 2 instances of Visual Studio running. Giving away all my secrets now. Right. So let's just get rid of that for the moment, so we can see the wood for the trees. We don't want the Pico console. We want that. In fact, that's sort of irrelevant for here. Okay. So back to where I was. So here we are. I want to edit this particular file. So I do rmate GPS test, and you'll see that there you go. It's now appeared in my Visual Studio Code. So I've now got this file called GPS test. So I can now start typing code in here. So I'm going to say, I'm going to put a comment at the beginning. So program for BAA rag demo. And we'll say print typing here. So at the point where I'm ready to try this out, what I'm going to do is I'm just going to do file save, and you'll see that it saved it, but it's actually saved it on my Raspberry Pi. So if I go back to PuTTY, if I do if in here, if I do ls now, you'll see it says undefined. That's good. I like that. No idea what that means. That worked well. What's undefined? This is Tomorrow's World thing, isn't it? Okay, when it all goes wrong. Oops. Let's just go out of this and try that again. Of course, this works the day in, day out, but the day you want to actually use it. Oh, it's not working now. Oh, lovely. It's such a good demonstration. Somebody's asking me a question now as well. I love live demos, shows what we all have to suffer. Yeah. Yeah. This I use this absolutely on a almost like on a hourly basis, and I've never had a moment's trouble with it. Of course. Why is that? That's completely hung up now. Let's shut this session down and start again. I don't think it is that, but Zoom's really slowing this machine down, hasn't it? It's really peculiar. You're supposed to be really impressed by this, because the first time I started using this, I thought it was absolutely awesome. I honestly have never had a moment's problem with it. CUD array until now. So I've got this thing called undefined, which I don't like the look of, but it doesn't matter. Rmate test.py. Right, it's come up this time. Okay, so I'm just going to say print hello rag. Stopped. Oh dear, something's gone weird now. What the bloody hell? Oh dear. I've got a key that's stuck. Every time I press a key, something weird happens. Oh no, nothing's working. Hey, this is cool. This is really cool. That works. Why is my save? Right, I just want to demonstrate this working. Keyboard's gone. Whoa, everything's just gone. Is it all gone? I've got a key. I think I've got a keystroke stuck down, and when I hit buttons, stuff just leaps around everywhere. It's like a control key that's stuck or something. Oh, it's blinking again. Oh no! Well, I'm there. Oh, fantastic! What's that? I have no idea. I wasn't expecting this. Oh, let's turn speech recognition on. Yeah, that's good. Help! Nothing's working. I can't type. What I'm going to have to do at this point here is shut Visual Studio down. I don't know whether it's to do with Visual Studio or whether it's to do with something else. Am I able to type in? Nope. Every time I hit a key, I just get craziness happening. Something to do with the keyboard. What can I do? I don't know. If I do A, that I've just typed an A then, and I get that. If I type an S, I get that. I think we're done. Right. How do you get out of that one? That's not how I wanted to end this workshop. Let's have a break. Well, yeah, let's have a 5-minute break and see if I might have to restart my machine, because I think there's like a key stuck. I mean, I've had this before and you can get out of it and I can't remember what the hell you do, but I might have to just restart the machine and come back into the meeting. So I'll see you back here in 5 minutes. Okay. Check the keyboard. Yeah, good idea. Oh, man. What the freaking all right.